Hello everyone. In case you missed it, consumer AI seems to be all the rage right now on crypto Twitter, and leading that wave is of course Luna, which is I guess a live streaming agent, an AI agent that is able to interact with viewers, and then more recently able to tip uh, her her viewers. So the reason why I'm making this video is because I want to show you, what angles you can take when you're analyzing these sort of like new things that come up on crypto Twitter instead of the usual, count transactions, count whatever, right? What other angles can you look at? So this video is meant to do just that. So my first advice, so I have all the advice here, but my first advice is to be active on Twitter, and you'll be able to catch uh you know new things like this thing, and try to follow people who are very active, like voicing out opinions, voicing out things, and you'll be able to find, if the founders are active, in which case they are for virtuals. You'll be able to find their Twitter and their conversations. And so that's how I got to find, I guess, one of the founder for virtuals called Ethermage. And uh, yesterday they posted something like, they found that Luna, the AI, was f- uh, did her first on-chain transaction, which is just sending over some Luna to some address, right? And based on this screenshot, we already have the transaction hash, and yeah, seems like it's a tipping transaction, and so we can use this transaction hash, plug it onto Basecamp, and then find the address where the tipping occurs, right? Yeah, you can type it out yourself, but I think there's a conversation here where someone asking like, should we assume this is the address? And then let's just copy this address and see what is it. Uh, yeah, if you see a bunch of zero here, that means there's no ETH transferred in this transaction. So maybe there's ERC20. So you click on the ERC20 tab, and indeed, if you look at the transactions or the transfers where it's initiated by the address, the left side here is the address, you will see that there are a bunch of tips happening, right? 10 tokens up to 100 tokens tips. And so now, without doing really anything, just by being active on Twitter, we are able to really find the tipping address, right? Which is this. And then, uh, yeah, like, um, if you continue on the conversation, or if you're active on Twitter, you can see that the founder actually say, the original address, which is this address over here, is the Coinbase MPC wallet. That's the one she has control of. So that's the wallet. So this is the wallet that the Luna, I don't know what to call it, agent, the Luna AI has control of and is able to use to send Luna tokens to other people, assuming viewers or uh, her Twitter followers, right? And then he goes on to mention she has other wallets like a tipping wallet when people live her 24/7 ad. So I'm guessing what they meant here is like there's another wallet where uh, the Luna agent receives when people tip her during the live. So what does this mean, right? So to understand what this means, the next advice I have is of course to try out the actual protocol itself. So just go to the website here, this link over here, it will bring you to this page where you have this page is all about Luna, and then this is the price, and then this is the live stream. Not sure why it's not working at the moment. And on the right here, I see a function to uh, send Luna tokens, essentially tipping the Luna agent. And that's exactly the what this guy mentioned, right? Where it says she has other wallets, like her tipping wallet when people tip her during her life. And so to know what is exactly the tipping wallet, we will just try to simulate this transaction without actually going through the transaction. So here's what I mean. Right? So if you are connected already to the site, and just buy like a little bit of Luna just to see what happens, right? In this case 42 Luna, just click on this. I just click on it, and the MetaMask pop-up will show up, and then it says here, this is you are sending, this is the Luna token, and then yeah, you're sending 42 Luna, right? But if you go to hex, which is the raw call data, you will see that it is a function, right? Transfer address and int. This is pretty straightforward, which is just the first variable is an address type, and then next is a integer type. And so if you wanna decode this, you can, which is just this is the address, and then this is the integer, right? Pretty straightforward. But you don't have to do all that. You can just click on this, which is, it says this is my address. I am interacting with the Luna token, and the Luna token calls the transfer function, and it sends to this address. So if I click on this address, how do I copy it? Here, and I go back to base scan, and I'm very certain this is the tipping wallet, right? Where when people tip her during the live, this is the wallet that receives all the Luna tokens. And so if you click on, right, like click on all, you see that it's about almost 200 transactions. People are tipping here, right? So this already unlocks, a lot of different things you can do on this. So let's just try to write this down, right? So first, this address over here, Luna by virtual, is it virtuals or virtual? Virtuals, okay. And then the first address is, of course, this one. Let's call it like this. Oops. And this is the tipping wallet, the wallet that Luna uses to tip other people. On Twitter, I've seen like people putting their addresses in their bio, and then Luna would tip them. And then the other address being this wallet that receives Luna tokens when people tip her during the live stream, right? So just by trying out the protocol, you already have some information on what things you can analyze, right? For example, in this case, you can look at tipping. Tipping, for example, like who tipped the most, right? And then maybe you have a hypothesis like this sort of tipping can bring in liquidity. So maybe look at use the cross-chain bridge table, find all the ones that bridge to base, right? Count the volume and then see what drives liquidity essentially. And yeah, that's the thing that we can do so far. What else? Okay, so another tip I have is to I guess I've written down here. Think about, actually, yeah, I've actually just covered this, which is first try the protocol and then think about what actions can the user take on the protocol or as a result of the protocol, right? In this case, users can tip, then they might bridge liquidity to be able to tip more, right? Or maybe swap more than to tip, right? So of course you can add swap here as well as one of the user actions. The other being another protocol action you can do is, because this is a website for anyone to create an AI agent, you can look into creating an AI agent. So if I click on create an AI agent, it tells me that I would need 2,400 virtuals token or 135,000 virtuals token, right? And I'm assuming these are on-chain transactions. Okay. Now the way you can do that is, first, of course, if you have money, you can always just buy this amount of token and then try to create agent without going through and then seeing the MetaMask pop up like I showed here, right? Clicking this and this. But of course, you can also, I mean, the other way is to look at click through all these different agents and see how are they being created. So one example is, let's say Luna, right? The token address is here. So I'm gonna copy that, paste it onto, let's say here. So this is the Luna token, and we can look at the transaction where it is first created, right? So first thing I'm noticing is that it's a migrate agent function. And then if I roughly look through what's happening here, null address means something is being minted, and in this case, a billion supply of Luna token is being minted. Now, at this point, I would say it is also good to read the documentation. So just look up virtuals docs. I did take a brief look at the virtuals docs, and from there I know that, when an agent is created, they mint this amount of tokens, and then pair it with the amount of virtual token liquidity that you selected during the create agent phase. So remember, when we click on create agent, and then we can select how much virtual we want to provide, this goes into the initial liquidity of the pool when the agent is being created, right? So created this amount, minted this amount of tokens, and then the agent creator gives the virtual tokens, right? And now this virtual token is able to use these tokens, pass it on to this guy, which is the actual pool itself. So they created the Uniswap v2 pool, right? And then they mint the LB tokens. In this case, the LB tokens is this amount, right? And then let's see what else. After minting the LP tokens, they hand it back to the owner itself. Oh no, they hand it to this contract, which and in turn for giving this contract this amount of LP tokens, they give the deployer the same amount of this thing called staked Luna. So definitely there's something here that can be found in the documentation, like what exactly is this staked Luna. From what I've seen, it seems like they sort of give up their control over the LP, and in return they get this staked Luna token, which I'm assuming they can redeem at some point, right? So that's roughly what I can get just by looking at the ERC20. Now let's look at logs. Because there is a Uniswap v2 being created, so there's a lot of Uniswap related stuff like pair created, right? Whatever. What I'm interested in is I'm trying to find events from this address, which is 41A. So maybe I'll just search for 41A. Okay, so looks like there is one event emitted, and it's called agent migrated. They tell you the virtual ID. I'm just guessing this is the ID of the agent, and then this is the Luna token, which was just being created. The LP token, so that the pool address, and then I don't know what this is. I don't know what that the DAO is, right? Um, yeah. So one quick thought is like we can already get the event, like filter for this agent migrated event, get the token, um, or rather get the LP, and then get the first mint. Let's see, there is a mint transaction somewhere. Okay, there you go, right? Get the first mint and then get the amount 0. So amount 0, I'm guessing amount 0, sorry, token 0 refers to the virtuals token. So the reason why I'm trying to get the mint is because I can then join the two and then say, okay, this agent is being created with the 125,000 virtuals token instead of the 2400 token, right? So that's how that's another angle of analysis, meaning you look into agent creation and you can think about like what like what is how much the deployer provided in liquidity during the initial phase. So let me just write that down here, right? Another angle is look at agent creation and then look at how much liquidity was provided in the initial mint, right? Another thing I'm curious is that it says agent migrated here, but I don't know why. Usually it's like agent created, right? But I know I'm pretty sure if you read the docs, there'll be something. But another thing you can do is instead of going through the docs, you can actually I would click through some of these agents and see how they are being created. Are they the same? Do they have the same process of being created? Similar to Luna, right? So let me just, how do I click into this? I guess, and then click into this one. This is a token. Duplicate. Oh, okay. So immediately this is different, right? It was migrate agent before. Let me just go to here. You can see here is migrate agent. In this case, the function call is, I mean, they just found mint. A base scan just found a mint, but not migrate agent. So that means there are some things different here. And another thing I'm noticing is that the origin contract is also different. Right here it is 41A, and here is 94B. So I'm going to look at logs and then try to look for 94B. And okay, so it seems like this is another contract where users can create the agent, right? It says here new persona. It has the same virtual ID, LP token, and also the token address itself. And then yeah, it looks like the same process, but for some reason there is a migrate function here. So what I will do is I would first look into this address, and then I would see that all the origin functions, which is propose agent and execute application. So propose agent. Oh, okay. So it looks like this function. Anyone can propose. Oh, okay. So if you click through create agent, and then whatever you choose, and then if you click create agent, I think that goes to propose agent, like this one over here, and you send this amount of virtual to the contract, and then in the next in the I don't know what's this, like a few blocks later, someone, which is I'm guessing, I guess it's the virtuals team, I'm not sure, but someone then executes your application and goes ahead and makes all the stuff. C86. C86. Interesting. Okay. So a good example of why you cannot use origin from address in this case is because the original proposal is this one, right? C86. They propose the agent, but then to actually execute on the application, which is the actual creation of the agent, I'm guessing someone from the team goes ahead and approves those and executes those. You can see if I highlight, hover over this address, all the address light up, which means they're the same. And so if you were to use the origin from address, you would just be getting the team member's address, not at the actual, person that proposed um, the agent. Okay, so here's what I do. I would use this contract, this 9-4b contract, look at event logs, try to get all of these agents created, and then try to see if the Luna agent, which was agent number 42, appears in here, right? And if it does, then that makes sense, because now we can say, okay, so looks like there is this current contract and then they would have to migrate to a new contract for I don't know what reason. So let me just copy this and then say this is the migrate agent contract question mark, and then this is the actual agent creation contract question mark. You can of course go through the contract itself, but I'm not gonna do that. Just roughly based on this, we can already try to figure out some stuff, right? So the first thing I'm gonna figure out is find all agent creation from 9-4b, and then 2 is validate if the Luna agent virtual ID 43, is it 43? 42 exists in this event. Okay, so let's try to do that. Let's do a little bit of SQL on Sunday as usual. So what I would need is this event. Maybe let's also look at the traces. So I'm gonna paste this here, change this to base. So this is a block explorer that's very helpful to look at traces, called blocksec. Alright, so then I'll usually just click on expand all, and then I can see that execute application and then initialize. Okay, this is the Uniswap stuff. Pools, get packet reserves, voting, so some DAO related stuff. Next virtual ID, okay. This means new validator. Oh wow, okay. Stick is true. Okay, so looks like there is a name in the initialize function, are there names anywhere else? No? Okay. Yeah, we can actually make use of this. So how we would do is we would just filter for traces, filter for this as a to address, filter for type is delegate call, and then filter for the function um, this input over here, this function signature over here, which is to be initialized, and then we would just grab just grab this. We have the token, which we can then join on. What token is this? Oh, this is the NFT 31AC. Oh, it's the VE token. Not sure what's that. Locked something, I guess. $5072. Are there any? No. Okay. Interesting. Okay. Yeah, I guess we can query the traces table just to get the name if you want. Then we can join in. But my concern is that there's no proper way of joining. Let's look at this further. So oh, there you go. This initialize has the name. Oh, staked. I see. Okay, never mind. So I will want this initialized then. Name, and then I guess we can join this token, right? Which is the apparently it's the VE token. So that will be our joining condition. Yeah, let's try to do this. Okay, so first up, event logs, right? So oh, this is 5 minutes ago. Is there like something with a bit more delay? You know what? I'll find it. Select all from base, easy, decode the event logs where contract address is this, and then I need a lower block timestamp. I think it's October 28. Oh wow. Oh, I forgot the event name. So what I'm doing now is I'm just trying to look for event logs for this particular contract, and there's no data display, which means we do not have the ABI for this contract or its implementation contract. So you can go ahead and submit the ABI for this. Maybe I will actually show you how. So let's see. New persona is, yeah, this is the contract, right? So this is the proxy, and it relies on this address, which is the implementation address. So we can go ahead and go to ABI requester, and then go to base, click on the implementation address, which is this. Let's copy it, boom, and then click find the API. That's the API, this one. Copy this thing and then paste it here, and this is my Discord handle. And then you can click check for issues. If there are no issues, then you can hit submit. There you go, submit, boom. Okay, cool. So we don't have the API, that's fine, we will just use event logs. But before using event logs, I will need to find a, let's just use this 3 hours ago transaction. So execute transaction, this one, October 26. October 26. Event logs. Oops. Oh. Wait, what? Where contract address is this, and then tx hash is this. And then we will want the topic. So the topic for this would be this over here. So topics. Alright, so yeah, and we have the topics and the data, and all this data is like all this stuff over here. So I think we just want the virtual ID and also the VE token to be able to join back. I mean, you can get the token as well, which is the agent token itself. So to decode this, I would just need to cut it up into strings of 64 characters long, and I need to find my previous stuff. So I don't know where. Oh, there you go. Nice. Okay, cool. Alright. Oops. Nope. This one. Okay, cool. Alright, so let's see. Yeah, this looks right. So this just means take the data column, remove the first 2 characters, which is OX, and then cut out all this into lengths of 64 characters long. And that just makes it easier to analyze. So the first one would be then virtual ID, which is an integer. So I don't know, let's call it sec sec 0. Utils.udf hex to int as virtual ID, because I'm converting hex to int because the first one is an integer. If you hover over it, it says integer. You can just see from here, integer. And the token is address. The second one is an address. So for address, you don't need to convert. You just need to cut. So substring. This is all fixed, by the way. So once you know what to cut, you're good. I think it's 25. Yeah. We'll validate that with the on-chain data after this. Where's my concatenate? Oh, here we go. Okay. As agent token address, and then the last thing we need is the VE token, which is to be the one we'll be joining with traces. So 1 2 3 4 5, or 0 1 2 3 4. So this would be 4. Alright, let's validate the accuracy. Duplicate, oh okay, oops. This is the VE token. So the error there occurred because I have two columns with the same name, so I just renamed the column. Alright, cool. Let's see our results. Virtual ID 425, is that correct? It is. Agent token address is 0x5ff. Okay, that's the one. And then VE is 0x9381. 9381. Okay, cool. Ends with 2078 and ACC. Okay, cool. So all this matches what we see on Basecamp, which also means like this is the standard that you would use. So in data, if you're using event logs table and in the data column, it would be 25. But if it's I forgot what's the other one, but the other one is 27. I don't remember. But yeah, always concatenate substring it out and then check with the sources if the address is correct. Alright, so now we've gotten the event logs down. Now we need the traces, and the reason why we need traces is because we want to be able to get the name of the agent itself. It's not necessary, right? But it's nice to have. And also I want to show you how to use traces. So I'm gonna look for name. In this case, the name is Douche Bigelow. Okay. I'm not sure if it's safe for YouTube, but okay, let's try to get this one. So first I would need again to address this one. So for traces, roughly the same amount of filter, right? Instead of contract address, we just use to address. So to address equals to, and the to address here would be this address over here. And then block timestamp transact hash is the same. No need to filter for topics, but we do need to filter for type. And this type is a delegate call, which is written over here. And then the function is initialized, and the function has a function's nature of this. So I'm going to copy this and then say left input is this. Right now, I'm gonna do one more step and also just add this in, which is my substring. Oops. But because we're working with traces, this needs to change a little bit. This needs to be input, and instead of starting at 3, we will be starting at 11 because the function's nature is 10 characters long. But I think that is it. Let me just run this. And while that runs, how you would decode traces compared to events. Events, you just look at the here, right? It's very straightforward, right? But for traces, you would click on the contract itself. It's called initialize. Go to contract, scroll all the way down to ABI, copy the ABI, go to this site called JSON beautifier, or really any beautifier, and then look for initialize. So this is an event. I don't want an event, I want the function. There you go, type function initialize. And yeah, this is all the inputs in this trace, and you can then decode this using this API. If you want to know more about traces, I have I have 3 videos on traces. You can go and look, watch those as well. But this looks pretty straightforward. It literally just means, just take it. Yeah, there is no weird tuples or whatever. So the first thing would be name. Second thing would be the token. Yeah, agent FD, whatever. And we've come to know that the token is the VE token, right? And 9381. Same with this 9381 VE token. So we want both the token and also the name. So let's get those. So yeah, first would be name. So sec 0 is name. Now name is interesting. I believe it is hex to string, and this would be the name, and then the next one would be the token. And because it's a token, we would just have to use this as the V token. But this is a little different because if I'm not mistaken, it is 27. But we'll see. We'll just run this and see what we get. Okay, so yeah, it looks like the token is correct, which is this value over here. Let's just verify that. Yeah, AACC. Okay, so it looks like this is correct. And our name is, there's nothing there, so let's look into why that's the case. Oh, I see. Okay, so this is there is a offset, surprisingly. Why is there an offset? Interesting. Okay. So how I know it's an offset, because this looks like a number. It can be converted into a number. So let's look at what this offset is. Hex to int converter, and then convert this to this one. So 160 divided 32 is 5, so I need to skip 5 lines. No, it's easier if I paste this here. Right, skip 5 lines, so 1, 2, 3, 4, 5. Oh, is it because it's in, oh shit. Ah, damn it. I didn't look at the type, that's why. Gonna copy the ABI again and see what's the type. Initialize. Yeah, it's string. String address. Okay, I guess the string is very big or something. Let's copy our this again. So 1, 2, 3, 4, 5. This is another number. What number is this? Oh, that's not a number. Wait, really? Oh, there you go. 1800. So I'm guessing 1800 means, yeah, it's not. So it is number of characters. Huh. Token, so address, threshold 0 is threshold, voting period is uint32. No, this is voting period. Oh, 1, 2, 3, 4, 5. Okay, sorry, my bad. This is the string. Yeah, 43 characters. So the next 43 characters, which would mean I don't know, this looks like bytes, no? Why is it string? I don't know. But yeah, this looks like bytes, in which case 43 I need to times 2. 43 times 2 would be 86, and this would be the number of characters. The next 86 characters is the thing that you want. So I'm just guessing it's like this plus this, right? Because this is 64, and then this is whatever how many this is. So you just create a new one called hex to string. And then copy this. Okay, so yeah, we've got the name. No difference. Okay, so yeah, that's the name. And I guess the reason is because if the string is too long to fit in one single row, which is 64 characters long, there will be an offset. Okay, this is the first for me. So which means now I'm thinking if all names have offsets or only some names have offsets. This is an interesting problem. For this, we have to assume it's the first is an offset. So I would have to say this is hex to int name offset, right? So in this case, this would return 5, and then the fifth one, the sixth would be the length of the string. So util.udf. This is actually very similar to the traces video I did. So if you are confused, you can also watch that that video. I think it's traces v part 3 or part 2. And this gives us this need to multiply by 2 as name character count, or yeah, sure, why not, right? And then that tells us the next line. Yeah, that tells us the next line how many characters we need to cut. So let's see how to cut this. I don't know how to explain this. I'll try to explain this. So we want to have we want to start cutting from the 6th line onwards, right? Which means all these 5 lines, or rather these 6 lines, 2, 4, 6, needs to be an offset. So we can actually use the whole the raw data by itself. And so the way we would use the raw data by itself is we need to count how many characters are there in these 6 offsets. So substring the raw data, which is input, starting from which character. And because there are 6 lines, we need to start from the 385. How many characters would be this? And that would be our substring. And now we need to convert this to a name, which is utils.udf hex to string as name. Okay. Hopefully that should work, but yeah, we have to go through all this is because the name is too long. Oh, okay, looks like there is something wrong. Name character count is now. Why is that the case? Name offset. Oh, I forgot to divide by 32. So that should give us 5, and then yeah. Let's see what other errors we face. Oh, there you go. So we did have the name, but it seems like it is cut wrongly because we're missing out on some names here, right? So if you go back to, we should have we shouldn't have the plus, and we should have virtual's DAO. In this case, we do not have virtual DAO, just have virtual. So I think we cut wrongly. So let's look at it again. Name character count is 86, which is correct. Input 385. Oh, input has an additional 3, additional 2, additional 10 for the function signature. So which means we actually, the calculation is 6 offsets, which is 385, 384, 384 plus function signature, which is 10, and then plus the 1 for the starting number. So this would be 395. And let's run that, see what we get. Okay, there you go. So we did successfully converted the name, and we got the name. So there's that, and then now we need to join the event logs with the traces. So let's just do that. With logs as, and then call this as like traces as, and then select from logs. Maybe just left join traces using transaction hash and VE token. And then what we want is the virtual ID. You know what, this whole thing. Virtual ID, the token address, the VE token, and then if possible, a name. And that should give us the information. And then you can extrapolate this to, you know, find our initial goal was to find if the Luna agent exists, but I'll leave that up to you to find. Voila, there we go. Right, with the name, we have the virtual ID, the agent token address, and the VE token. Yeah, so that's exactly how you do it. I guess my point for this video is I want to show you how, you know, what other angles you can take to analyzing protocols like this, instead of, you know, the usual count transactions. If you're still at this point in this video, thank you so much for watching, and yeah, I will link my query in the description, and I appreciate all the likes, follows, and comments as well. Thanks everyone. Have a great Sunday. Bye.